Hello, I hope you did well on 2.1. This is 2.2. It's just more of the same. We're talking about functions, domains, and range. We're going to talk about increasing, decreasing, and about max and mins. So I hope you're ready. 2.2 notes out, and let's go. All right, when we go through this, the first part we're going to talk about is intervals, or where it increases and decreases. This is just fancy language for saying if the point before is less than the next point, then it's increasing, or the point before is less than the point next. So this one is less than this, is less than this, increasing. X1 is the opposite. The point before is greater than the next point, is greater than the next point, it is decreasing. If they are the same, then it is constant. Nothing major, just wanted you to realize how that's read. Okay, so we go here. When you do this, you actually go off the X value. So you look at your turning points. There's a turning point here, and there's a turning point here. So my function is changing from a negative infinity to 1, then it's changing from 1 to negative 1, and then it's changing from negative 1 to positive infinity. Now we have to see what it's doing where. So in this part of the section, you look, the graph is going up because you always read left to right. So it is increasing from negative infinity to negative 1. Right here, I think I said this wrong. This is negative 1 to positive 1. And then from negative 1 to positive 1, it is going down. So it is decreasing from negative 1 to 1. See how they start over? So my next section, it goes from 1, sorry I did that again, to positive infinity. So it is increasing there. All right, try yours. Make sure you're pausing the video. Okay, your sections are from negative infinity to, that's a terrible infinity sign, to negative 2, negative 2 to positive 2, then positive 2 to positive infinity. So now let's see what they were doing. From negative infinity to negative 2, it is going up, so it is increasing. So say it's increasing from negative infinity to negative 2. From negative 2 to 2, it is constant. It is not changing. So constant from negative 2 to 2. Now from 2 to infinity is going up again, so it is increasing. So I have another increasing part from 2 to infinity. This graph is decreasing nowhere. Okay, next section, max and mins are your turning point. Remember, this is a relative max because technically this is going on forever, so these points are higher. This is a relative min because technically it is going down forever, so these points are lower. Relative means it is a turning point. So our turning point is negative 1, 1 for our max. And then for our relative min, it is 1, negative 1. I hope you did well with that. All right, next we're going to talk about test for symmetry. And we're going to make this a little easier than what it says. A test for symmetry means if you plug in negative x and you get the same thing back, it's even. If you get the opposite of the function back, it is odd. So we know that this is y equals x squared, or f of x equals x squared. Now when I plug in a negative x, so f of negative x, this is equal to negative x quantity squared, which is x squared. The original and the negative are identical, so it is even. Down here, we know that this function is x cubed. So we know this is y equals x cubed. So that's f of x equals x cubed. Let's plug in our negative. So f of negative x equals negative x quantity cubed, which is negative x cubed. They are exactly opposite, so it is odd. All right, now let's try this next one. I have, and we're not going to do this, we have x to the 5th plus 1. So now let's find h of negative x. So I plug in negative x, we get negative x to the 5th plus 1, which is negative x to the 5th plus 1. Well, if you notice, the negative x to the 5th is opposite, but the plus 1 is the same. Since it didn't fully change or fully stay the same, then it's considered neither even or odd. All right, I should have given you practice. Okay, piecewise functions mean there's more than one part to them. When you look here, we have two lines, so we have two sections we have to graph. The first one is y equals 3. I'm hoping you remember that that is the line on 3, whoops, that's not very straight, of y equals 3. So it goes like so, right? Okay, this part here is the domain. It can also say if instead of a comma. So this says x has to be less than or equal to 1. Well, if I go, and my line disappeared. If I go to my line at -1 right here is the point they're talking about. It says less than or equal to, so it's a solid line. It wants less than, please stay solid. So it wants this half, which means this part over here has to go away. So we just erase it. Okay, that is one method of doing this. The other method is this. I can say it has to be -1 or less, so you plug in -1, -2, -3. It's 3, so nothing changes, so it's -1, 3, -2, 3, -3, 3. Graph those points, so -1, -2, -3. Draw your line on forever, and that's the first piece of your function. My next piece is -2. So we have y equals x minus 2. Now I know that means I start at -2 for my y-intercept, and it's up 1 over 1 for the slope. So we're going to draw our line. Hopefully you're using a straight edge and doing better than me. Now it is also good at x is greater than -1 this time. So now I go to -1, I go down till I hit my graph. Greater than means it's an open circle. And this time I want to keep everything greater than -1, so I want to keep the part to the right. So this part has to disappear. Okay, and that gives us our piecewise graph. If you do not like that, you can plug it into a table. So this is -1, so I'm going to plug in -1 greater than means I'm going to use 0, 1, and 2. So you plug those in here. -1 minus 2 is -3, which is where we're at. 0 minus 2 is -2, which is our y-intercept. 1 minus 2 is -1, so we're up 1 over 1. And draw your graph, and it goes on forever. 2 methods. Hopefully you don't want to do the table because that takes a long time, but you're welcome to, especially if you need to check yourself. Okay, next, this here is going to continue on to something in calculus. All right, it's very important, so it's a first step. It's actually first step in derivatives. But what we do is known as a difference quotient. You take f of x plus h minus f of x. So you really have two things you're doing with here, f of x and f of x plus h, and then you divide it all by h. So you are given this function. Your next step is to plug in x plus h in for all your x's. So we do that here and here. Square your x plus h. X plus h here doesn't do anything. Distribute your -2 and look to combine like terms, which there are none. Now we plug it into our function up here, which is always the same. It never changes. So we take our f of x plus h, so this is f of x plus h, and we subtract our f of x, or our original. Now I distribute the negative through. You combine like terms, so if you look, the x squareds cancel, the x's cancel, and the 5 cancels, leaving us with 4xh minus h squared plus h divided by h. They all have an h in common, so we can cancel those out. This one's gone, this goes to an h, and this goes to a 1. And you are finished. Okay, try yours. Okay, your first step should have been to find f of x plus h. So you plugged in x plus h squared plus 3 times x plus h minus the 2. So you have x squared plus 2xh plus h squared plus 3x plus 3h minus 2. Nothing combines. So this is our f of x plus h. So remember, it's the f of x plus h. So we're going to write that first. So we have x squared plus 2xh plus h squared plus 3x plus 3h minus 2 minus my f of x, which is my original right here. So we're going to subtract x squared plus 3x minus 2. If you can do that all in one step, please do so. And then we're divide it all by h. So next, we're going to distribute the negative through. So I have nothing changes on the first, x squared plus 2xh plus h squared plus 3x plus 3h, whoops, can't write, h minus 2 minus x squared minus 3x plus 2. All again divided by h. So here our x squareds cancel, our 3x's cancel, our 2's cancel. And we are left with 2xh plus h squared plus 3h divided by h. The h's are all going to cancel. So we have 2x plus h plus 3 for your final answer. Good luck on your homework. I hope you do a great job.